Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by getting the data and runtime right. First, prepare a focused dataset, clean, labeled, and deduplicated, so training converges faster. Next, set up a Python virtual environment, install PyTorch or TensorFlow, and verify CUDA GPU drivers. This avoids wasted epochs. Choose a small base model to fine-tune rather than training from scratch. This saves weeks and thousands of dollars. Once done, validate sample records and confirm you can load the model on one GPU before moving on. You now fine-tune with efficiency in mind. Apply parameter-efficient methods like low array so you only train a small subset of weights. This keeps costs low and speeds iteration. Configure hyperparameters conservatively, batch and learning rate ranges above, and run quick validation passes to detect divergence early. Use mixed precision, FP16, and gradient accumulation. These let you use larger effective batch sizes on limited GPU memory. Once checkpoints behave well, you finish by packaging and serving the model reliably. Containerize the model and serve behind a lightweight API like Fast API or a specialized inference server for batching and lower latency. Implement monitoring for latency, GPU memory, and prediction quality, and keep a rollback checkpoint ready in case behavior regresses. If the model hallucinates or drifts, add retrieval augmentation or a small instruction tuning pass and log failing prompts. If things still fail, reduce batch size and enable FP16 to avoid OOM errors.
Thanks for watching. Consider subscribing if I helped unscramble your problems.